Hi everyone, my name is Thomas Kim. Today is June 23rd, 2021. This is my 16th episode about must-know C++ 20 syntax and Qt6 3D graphics with Vulkan. In this episode, I will explain how to create compile time math library. We will implement sine function and cosine function of trigonometric functions. We will be using Taylor series. We will use mathematical constants. For mathematical constants, please double-click this link. Since C++20, a new header file called numbers. In this header file, these math constants are defined. We will also use trigonometric addition formula, this link. We will be using sine angle addition, cosine angle addition. We will be using Taylor series in this link. If you scroll down, you can find these Taylor series. We will also need trigonometric functions defined here. For example, in this equation, if theta plus this angle is 90 degrees, then sine theta equals cosine this angle. This formula is very useful. I assume you have watched my previous videos listed here, especially episode 15. Without further ado, let's get started. Start Visual Studio Code, open your working folder, select empty space, click this button, 0, 16, Math LIV. Click this button, Math LIV.cpp, hit enter. Control B. Include talk play fun, output HPP, include CMath, include numbers. Talk play fun, stream, auto, NL, talk play fun, NL. We will define some math constant, constexpr, auto, phi, std, numbers, double, pi v, double. Constexpr, auto, phi over 2, pi over 2.0, 90 degrees. Constant, constexpr, auto, degree, pi over 2, 1 degree. We will create a namespace, compile time math. End of namespace, compile time math. constexpr, auto, small angle, degree, 1 degree. We can control it later. Very small angle. After testing, we can increase this angle. Please remember, degree is 1 degree. So, small angle is 1/10 of a degree. Auto, absolute, auto x, return x greater than 0, x, otherwise minus x. This is absolute value, auto, cosine, auto x. This is forward declaration, auto, sine, auto x. If x greater than small angle, we are using this angle. else here oro cosine oro x if x greater than small angle else. Now here oro half x, we divide x by half. We will refer to trigonometric addition formula here. So sine alpha plus beta can be represented sine alpha cosine beta plus sine beta cosine alpha. Because alpha and beta represent half of x, we can say 2 times sine half x times cosine half x. So we can say return 2 times sine half x times cosine half x. Please understand that this is recursion. This is recursion. We are using this formula, sine angle addition. Also, we use recursion. Now, here, oro y, x is our angle. Double c x double xx equals minus x times x minus x square. Double n equals 1, while absolute c greater than tolerance. Scroll up here, constexpr oro tolerance 1.0 e minus 14. Now scroll down. I am using Taylor series for sine function defined here. So I will arrange side by side like this. C represent each term. C represents each term of Taylor series. Here we compute C equals x square negative. We multiply C this term. Initially we start x, then x times x, it becomes x to the third power, and minus, then C we divide n plus 1 times n plus 2. So n is initially 1, n plus 1 is 2, n plus 2 is 3. So 1, 2, 3, 3 factorial. We divide. At this point, we computed each term of the Taylor series. Now, y equals each term x minus x to the third power divided by 3 factorial. We add up the coefficient. Then we increment n by 2 for next iteration. n2 for next iteration. We return y. So we computed the cosine function. Now scroll down. Here, oro half x equals x over 2.0 or cs equals cosine half x or Sn sine half x. Return cs times cs minus Sn times Sn. Please note that we are using this formula where alpha plus beta is x. We divide x by half. So alpha and beta represent half x. We compute cosine half x, sine half x. Because alpha and beta are the same half x, we compute this value cosine alpha, this one cosine beta minus sine alpha sine beta. I will copy this link for your reference. Now, in the Taylor series again, we compute this part. Or y1 or c1 or xx minus x times x. I fix like this. Or n1. Sorry. Scroll up. I will change it to or. Now scroll down. In this case, we would set using type T 댓글 type X. It should be T. I will copy this, paste T. I will fix like this. Then while absolute C greater than tolerance C times equal XX C over equal N times N plus 1 Y plus equal C N plus equal 2. So this part we compute each terms of cosine x. Then we sum up the coefficient. Then we increment n by 2 for next term. Here return y. Now I will maximize it. Here for the test, compile time math or std sine degree times this is 10 degrees or compile time math sine. I will create a namespace alias namespace compile time math ctm sine degree times 10 into main. Copy this, paste it here. Stream std sine and then paste CTM sign, stream, std, precision 15. Now, in the command prompt, lib clang++, std, c++20, mass lib.cpp, ltbb, oc.exe. Okay. Control home. I will just put it double. We build again. CLSC. So std sign, we use C++ runtime function. CTM sign, we computed by ourselves. They are exactly the same. Now, let's try with a bigger degree. We build again CLSC. It works exactly the same. Let's try with the GNU compiler. GNU compiler also works correctly. Now, here, constable, also constable. Now, constexpr. We build again. CLSJ. We created cosine, sine for compile time math library. Please note that we used recursion here. We used Taylor series. Here also, for cosine, we used recursion. Here, Taylor series. This function cosine, this function sine is not yet perfect, but we can easily make these two functions perfect using trigonometric identities.